Okay, 5.NBT.7 is the big standard for the numbers in base 10 strategies and standards. This one requires a student to add, subtract, multiply, and divide. All four operations are in this one standard, and they're specific to decimals to the hundredths. Now, I'm redoing this video because there's something really, really important I need to explain about this particular standard being so large. Well, my app here, Exploring the Core for Elementary Math, when I look at the skills and how this particular skill in decimals has developed, first I want to point out decimals down here only really are taught, there's only standards in 4th and 5th grade. So if I look at 5th grade and I see that the standard is exactly that, adding, subtracting, multiplying, dividing decimals to the hundredths, and then of course there's lots of strategies and things to consider, but knowing these procedures, we didn't just introduce that, the concept of decimals was introduced with this standard 4.NF.7 in 4th grade. You were expected to compare two decimals to the hundredths by reasoning about their size and then compare them. So comparing decimals, that's not new. We do understand decimals, we know the concept of decimals. If we don't, then we need to go back to some 4th grade lessons and we need to really strengthen that concept and not just master or memorize procedures for solving anything involving decimals. So, with that being said, the actual solving of operations with decimals, that's where we are right now. So, that being said, let's take adding. Let's look at adding decimals to the hundredths. So first and foremost, if you are given two numbers like 25.1 plus 12.03, so that's 25 and 1/10, and you're adding 12 and 3/100. Well, you can add it left to right, where you're looking at the different place values and comparing them, where the ones are going to be added to the ones, the tenths are going to be added to the tens, the tenths are going to be added to the tenths. And even though this number, 25.1, doesn't have any hundredths, not having any hundredths doesn't stop you from adding these hundredths. So it might be easier to see if you line them up this way vertically to see how the place values actually line up, because then you can put in placeholders, especially when it comes to decimal places that don't have anything in it. So now when we add, it really is as simple as adding each place value from right to left. So the smallest ones we're going to add, and you get 3. The tenths will add, and you get 1/10. But the decimal always. And then the ones, we now have 5 and 2, which is 7 ones, and we have 3 tens. So adding decimals is just remembering to line up the decimal points so that you're adding the correct place values. And when it comes to subtraction, it's not that much different. If I take similar numbers, 25.1, and I subtract 24.02, I want to make sure that I'm subtracting the place values, the tens and the tens, the ones and the ones, the tenths and the tenths, and these 200ths, we are being asked to take 200ths away from no hundredths. So if we line them up vertically, it's sometimes easier to see how, if you don't have that place there, you can still put a 0 there so that you can remind yourself to borrow from the tenths, break that tenth up, to create 10 of these hundredths. 5.NBT.2 and 5.NBT.1 looks at the connection between place values and one being 10 more or 1/10 of the place to its left or its right. So you can look at those standards videos later. For now, as we're subtracting each place value, we can now take 3 hundredths away from 10 hundredths. And 0 from 0 is 0. We line up the decimals, of course. 2 from 5 and 1 from 2. So adding and subtracting, once you recognize that these zeros can be put in there as placeholders, then the adding and subtracting isn't terribly difficult. Decimals are not as complicated as one might think. So here's where we get into multiplication and division, and lining up decimals is no longer the key feature. Alright, multiplication. Let's take something like 25.03, okay, and let's multiply it times, I don't know, 25.1. Okay, so now whether you're talking about 25 groups of 25, or if you're talking about 25 groups of 25, the commutative property says you can multiply either one by either one. But for our example here, we're going to take the first number, 25.03, and we're going to multiply that times 25.1. Now what I want to point out is I did not line up the decimals. In fact, it's easier when you don't, and you might even want to pretend like they're not there. If you do that, then without the decimals, this is just 4 digits times 3 digits. And if you take each one of those and multiply each place value as if the decimals don't exist, 1 times 3 is 3, 1 times 0 is 0, 1 times 5 is 5, and 1 times 2 is 2, then suddenly multiplying by decimals doesn't get so very complicated. It's just a matter of keeping track of each step. 5 times 3 is 15. And notice how I'm putting the answer to multiplying by tens underneath the tens place. Okay? And 5 times 3 is 15. We carry the 1 so that 5 times 0 is 0 plus 1 is 1. 5 times 5 is 25. Carry 2. 5 times 2 is 10, plus 2 is 12. Alright, but now we still have one more place value to consider. Okay, and this is the hundreds place. So as we consider multiplying this place value, we have to make sure that 2 times 3 is 6. 2 times 0 is 0. 2 times 5 is 10. And 2 times 2 is 4 plus 1 is 5. So when we add up all of these numbers, 3, 5, 5 and 6, 6 is 12, carry the 1, it's 3 plus 5 is 8, and this is 2, this is 6. These are all the numbers we get, these are all the digits. Now here's where the decimals come in, and this is where calling this the ones place, the tens place, is hundreds place. That's where I can see how some of you might be thinking, but that's not the ones place, that's the tenths place. Right. With the decimal there, this is the tenths place, this is the ones place, this is the tens place. But just like we've learned how to multiply in 3rd grade and in 4th grade, in 5th grade with decimals, all I'm really considering is how many decimal places are we multiplying? In this case, there are 3. 1, 2, 3. And so we place our decimal 1, 2, 3 places over. And our answer is 628.253. And that's it. So whether or not you refer to these as ones, tens, hundreds, or tenths, ones, tens, if you want to be accurate, you may do so. But the point is, whether you put the decimals in before you begin, or whether you put them in later and count them, recognize that multiplying decimals is no different than multiplying any other numbers, and it's just a matter of recognizing the effect the decimals have on the answer. Notice there are no decimals here. Okay? Alright, let's move on to division. Now, when it comes to division, just like multiplication, everything we've been able to do with division doesn't change. So if we're dividing something like 25.853 divided by 2.51, my goodness, that's a lot of numbers. But what I want to point out is the thing that makes this standard 5th grade level is that the first number, as we know, going in front, the first number is the dividend, always. It's not the biggest number, it's always the first number. And the smaller number, or the second number, caught myself, 2.51 is the divisor. Now, the one thing that this standard requires students to learn is the divisor cannot be used as a decimal. You must get rid of the decimal. And 5.NBT.7 teaches that if you multiply a number times 100, you're not adding zeros to the number, you're actually moving the decimal, and sometimes the decimal moves so far that zeros have to be placed. So what happens is, when you multiply this times 100, 2.51 actually becomes 251. And whatever you do to one side, one number, you have to do to the other. And what happens is, you get 251 going into 585.3. And now you have a whole number that you can divide into this much larger number. And the only thing to keep in mind is this decimal is going to be part of the answer up here. Now, at this point, this is no different than 5.NBT.6 dividing numbers. Okay? Well, NBT.6 really only requires you to divide with a 2-digit divisor, but it's the same process, because 251 goes into 258 one time, so you put your answer over that place value, and then you get 251, goes in one time with how many left over? 7. You bring down the 5. This cannot go into 75, so you're going to put a 0 here, and you can bring down the tenths here. And 251 can go into 753 3 times. 3 times 1 is 3. 3 times 5 is 15. Carry the 1. 3 times 2 is 6. Plus 1 is 7. You subtract that, you get nothing left. And your answer is 10.3. Now what's important to notice about this is that the answer 10.3 is the answer not just for this answer that we just did, but 10.3, we're multiplying to check the division problem, but 10.3 is also the answer for this initial problem where the decimals are different in different places, 2.51. If you were to multiply these digits together, the only thing that would be different is the decimal. So 10.3 is the answer for this problem and this problem. So this initial division problem is going to have an answer of 10.3, even though we moved these decimals two places so that the divisor is a whole number. This, going from a problem with decimals to a division problem without decimals in the divisor, that's what makes this NBT7. That's what makes NBT7 so difficult for 5th grade, is remembering the differences between these processes, so that when you are given a problem, you can really look at, okay, it's asking me to divide. The divisor has a decimal, so I have to get rid of the decimal. How do I do that? Just like this, and now I just do NBT6 to solve and get my answer. So, NBT7, that's the big standard for students to really master and complete this NBT domain. Good luck. Message me with any questions. See you soon.